Hi, everybody. Thank you for joining this session towards the end of the day. Hopefully, it's a good end of the day for you after this session is done. So just a few pointers on the presentation itself. If you have any questions, you can use the Q&A function on the bottom right of your screen. You'll see a triangle, square, and circle. So within that, there's a Q&A function. That's the one that you can use to post questions. And we'll try to answer some questions as we go, but we'll probably save most of them for like towards the end, basically. So feel free to put them in there. So they'll stay in the Q&A backlog, and then we'll answer them towards the end. If there are some questions in the middle that we think are relevant and can be answered right away, we do that as well. Okay. All right. Yeah. So that being said, I think we'll get started. So the topic of our presentation today is related to RAGs, and RAGs are obviously very popular in the last few months. All across the board. You might have seen the agenda for TMLS all the days. A good chunk of it is, and no pun intended when I say chunk, you'll probably understand why when we go through the presentation, but a good chunk of it is related to RAGs and everything around RAGs. So to speak about specific components within the RAG system and a specific component that we've seen can present challenges. And essentially that component is the knowledge management component within a RAG system, right? So we've been able to build a modular solution for these knowledge management systems for various use cases and for a variety of different use cases, right? At Bell, and we intend to, hopefully present you with our learnings and what we've come up with, and hopefully walk away with this from this session a little more knowledgeable about knowledge management at RAGs, within RAGs. All right. Brief intro of ourselves. So I'm a senior manager of AI at Bell, one of the senior managers of AI, and Adam is a senior machine learning engineer within our team. There he is. So our team, basically Adam and me, our team, we are the ML engineering and ML ops team at Bell. And essentially, we help all the good work that the data scientists do in building models and building their Gen AI applications. We help them engineer and bring it to production, and all the operations and DevOps as well. So yeah, that's kind of a brief intro of what we do at Bell. Here's the agenda at a high level for today, and then we'll be diving into some of them a little more deeper. We'll obviously give you a brief overview and introduction to RAG. I'm sure most of you don't need it, but just in case you do, we'll try to capture a little bit. We'll go over some of the underlying concepts and basically the inspirations and motivations behind the type of solution that we've come up with and we've built. And that's really to sort of, set the tone of why we've built the solution the way we have. We'll go over problem limitations, essentially try to define the problem that we were trying to solve and all the limitations that we were across. Number 4 is obviously, the 4 and 5 are obviously what the session today is mainly about, is the solutions, and then the solution for the document embedding pipelines, and the solution for how we structure and maintain the knowledge bases. And then we leave some time for Q&A once we're done. All right, so an introduction to RAG. So RAG stands for Retrieval Augmented Generation, wherein you augment and optimize the output of a large language model so that it references a knowledge base outside of its training data sources before generating a response. So while Ross Geller, assuming is an LLM, would say Unagi is a state of total awareness, a RAG would probably correct him and refer to the right knowledge bases and tell you that no, it's not. Zanshin is probably a closer representation of total awareness, and I might be wrong there as well. Whereas Unagi is an eel. And then while Cliff Calvin will tell you that cows were domesticated in Mesopotamia and were used as guard animals in China for the Forbidden City, a rag with a proper knowledge base would probably tell you that whether or not they were used for as guard animals for a Forbidden City is not really supported by historical evidence. And credit to Adam for the memes in here. Hopefully, that tells you that our session's not going to be boring. All right, a few screenshots of, or like one screenshot, I guess, of one of the rags that we are using within our company today. So I work for Bell. If I were to just go to ChatGPT and ask them, okay, at Bell, I work for Bell Canada, how many vacation days do I get? It's probably going to give me a very generic answer that's going to tell me, okay, it really depends on your role, when did you join, those kinds of things. Whereas if the rag that we have, one of the rags that we have at Bell is for us to be able to know what our HR policies are. And if I went and asked that bot, I've been at Bell for a year, how many vacation days do I get? I'm going to get an accurate response because this bot is able to reference an extended knowledge base. Right? Okay, now just on a high level, if you were building a chatbot with an LLM, this is what the architecture would look like. Right? You would have an API in the middle that essentially is the prompt engineering layer. Right? So when a user interacts with the front end and sends a question like, how many vacation days do I have? The front end will send it back to an API layer that will add, a prompt layer on top of it and send the prompt to an LLM, get the response back, and then send it back to the user saying, how many vacation days you have really depends on how long you've been, et cetera, et cetera. The same architecture in a RAG situation adds a few more components, right? So the user has sent their query. The query goes to the API and prompt engineering layer. Now, the prompt engineering layer, in addition to adding the prompt, is also doing a few more steps, right? It's going to search for relevant information from the knowledge base that your RAG is feeding off of. And in order to, I guess, do that search efficiently, it's going to use the help of a vector database, right? So it's going to go to the vector database, search for use the query that the user had sent, search for the relevant information, now append that, send it to an LLM, and then send you a more accurate response back, right? And in most cases, it'll also be able to, or in the kind of solution that we've built, it should also be able to give you the actual source information. So it should be able to fetch the specific documents from the knowledge base that helped it give you the answer it gave. Right? So that is how a RAG architecture would be slightly different from a normal LLM chatbot that doesn't use RAG. Just very quickly, some benefits and challenges of RAG. Benefits, you can make your chatbot's response more accurate because it's referencing a specific domain and getting the right context. You can make your chatbot versatile because now you've given it different knowledge bases, so it can use those knowledge bases to then give you a response based on the specific use case. It can extend to a variety of different topics. It can also give you, like I kind of alluded to in a couple of slides before this, it can provide the source. So it can give you the actual document it was referencing when it's providing you with the answer, right? And if built well, any RAG solution should be platform agnostic. So it shouldn't really matter what LLM you put behind it, as long as your document embeddings, your knowledge base, and the pipelines for retrieving relevant information from that knowledge base have been built in a good modular manner. And obviously, with these benefits come challenges. So if you remember the two architectures that you saw with the normal LLM chatbot and the RAG chatbot and the RAG architecture, There were a few additional components in there. One of them was a knowledge base. Another one was the vector database that essentially indexes the knowledge base for efficient retrieval. And to create and maintain those vector databases and knowledge bases, you need embedding pipelines. So you've got more moving parts. And then the other challenge is obviously curation of the knowledge base itself. Now, most real world use cases, your knowledge base is not going to be static, right? It's going to be constantly changing. If we take the HR policies example from previously, HR policies are subject to change, even though not frequently, but they are an example of something where the knowledge base will keep changing, will keep getting updated, either keep getting added to or be replaced altogether, right? So you need your system to be able to sync to those changes in the knowledge base over time. And these challenges are essentially what we're going to elaborate and what we're looking to solve for and what we're presenting in this session today. So how do we take care of these moving parts, and then how do we efficiently manage all the changes in those knowledge bases? And then obviously there's the cost question as well in the challenges, where you've got more parts, there's more cost. But our focus today will be on essentially how do we handle those additional moving parts and how do we handle the different challenges that come with changing knowledge bases. So a few underlying concepts that we took inspiration from for building these solutions. Or I would probably extend that and say that Adam took inspiration from, because he was the lead engineer on the solution, so he's built a lot of it. But essentially, just because we're working with a solution that would go into a generative AI solution bucket, it doesn't mean that there's no concepts from traditional ML that would be applicable here. And then similarly, traditional ML, and then since we are building a product that needs to be dynamic and needs to be extendable, reproducible, and maintainable, software engineering best practices are a must. And one of the things that really helped us build this efficiently was trying to think of document embedding pipelines and knowledge base management as a product. And that's really what inspired us to make this very modular, right? So what was the inspiration from traditional ML concepts? I guess the main inspiration that we took was from a data lineage and data provenance perspective, right? So in traditional ML problems, making sure that your data is lineage and making sure that you're able to track data from source to your model ensures that you can explain the performance of your model and your system over time. So, one of the examples where you see that is when there's a drift in the training and serving data, and there's a skew between the training and serving data sets, right? Now, similarly in RAG, keeping track of the data from the knowledge base, like the raw documents, to being able to say, where it is embedded in what index, really helps us make sure that we know why the bot is responding the way it's responding, right? So, that's one of the uses of one of the reasons why tracking data lineage is important in RAGs. And the other one is because there are multiple ways to embed those raw documents into a knowledge base and into an index. There's different ways to chunk them. There's different ways to pre-process and post-process those documents. And also, there will be overlaps between documents, right? So keeping track of how the data has been processed and changed also helps us to keep track of be able to compare the outputs from the various pre-processing combinations, right? And then in terms of software engineering best practices and treating the solution as a product, we essentially focused on modularity, right? That was our main focus. We wanted to build a system so that each component of that system can be individually tested, changed, debugged, and scaled, right? So, it promotes reusability, maintainability, and scalability. And in that vein, we also made sure that each module has its own function, right? So separation of concerns within different parts of the system was an important aspect in designing and building the solution that we did. Now, this may seem like, just why are we going over software engineering best practices? But as we go towards a solution, you'll start seeing more and more relevance as to why we really focused on these principles when we were building the solution. Testing, we made sure, since RAGs and document embedding systems are novel solutions today, it doesn't mean that we don't build them with traditional software development best practices, such as test-driven development. Make sure there is a unit test for every single component. Make sure we're doing integration tests and so on, right? And obviously, the big one when it comes to software engineering best practices is making sure that all our changes in the component and the system we're building can be integrated continuously and deployed continuously, right? So the CI/CD pipelines that came with these systems are a big part of what makes these systems easily deployable and maintainable. All right. So with all of that, I hope I've set the ground of what were our inspirations and our thinking behind the solution that we've built. And now I'll pass it over to Adam to start with the problem limitations and then actually go into the meat and potatoes of this whole session, and that is the actual solution. So over to you, Adam.
Cool. Thank you, Lyndon. Much appreciated. Well done. Yeah. So problem limitations. So as any software engineering problem, in order to develop a solution, we need to define the constraints, limitations, and variables. So starting with the constraints and SLAs, in our particular solution, we're limited by GCP quotas. We're a primarily GCP platform team. So, and specifically located in the North America Northeast 1. So, however, you can expand these same ideals across other platforms, so on-prem, other cloud providers. Also, just a small note that these quotas are for a single GCP project level. So, really important governing constraint is LLM quotas. So, online API requests per minute and batch requests if your platform offers that. So, the base model test embedding Gecko, you're limited to 100 requests per minute. And for the batch requests, you're limited to 30,000 prompts per request and a concurrent 4 batch jobs. So as any, the bane of almost every software productionization out there is infrastructure. So compute resources for your pipeline, your vector database have to be considered, and then also your service level agreements, which is really important when it comes into the knowledge base and how we actually get documents into our solution. So when can we expect the documents? Will documents be updated in batch, or will some documents be updated intermittently or incrementally in real time? Do document changes need to be reflected immediately in a vector database and knowledge base, or can it wait for a predetermined period of time? So the next thing that we have to talk about are problems deltas. So these are things that can change within a RAG system. So now we have to define kind of the variables of the problem. So the 2 main deltas which can change in our system are the configuration delta. So all the configurations associated with our pre-processing and embedding components. So everything from kind of what Lyndon alluded to, your text splitting parameters, your separators, your model details, everything down to your atomic component parameters. So what project region, your source and sink you want to write to. And the second delta that can really change in your system is your documents, your document delta, which is really any time you have a change in the knowledge base. So anytime a document's uploaded or changed in your knowledge base, It could be a batch upload. Documents could be updated, again, intermittently. And if you combine your document delta with your your SLA that we mentioned on the previous slide, it kind of dictates your data velocity, right? How fast you require these documents to move through your system, or to move through your pipeline and be reflected in your knowledge base and vector database. So all this is great. We've, I would say, framed the problem, defined the problem. So what do? We have all this information. We can start cooking up solutions or combinations of solutions which kind of best accompanies all of the problem deltas, constraints, SLAs, which again takes us to the solution matrix that Lyndon showed here. So starting with, like, if you have any change in your configuration, or you have a large change in documents, they both warrant a batch solution. For the change in configuration, initialization and config changes necessitate rebuilding your underlying VD and KB on the premise that you can't have apples and oranges with your knowledge base. You can't process documents one way, and then when you're ingesting documents and comparing them, process them in a different way. If you're using two different models, for examples, or two different embeddings models, you're just, it's not going to work, right? So if you have a underlying config change, you have to basically rebuild everything. Now, that warrants a batch solution because, if you have a larger knowledge base, using online methods will consume your API quota, right? And if you are sharing your chatbot API with this project space, you will essentially, take down your API, right? Your incoming requests won't be able to be embedded, and you'll kind of grind your system to a halt. Same goes for large document changes that are delivered in a batch or interval delivery. It's the same scenario as your Delta config. They do take time, and you need to ensure that intervals are spaced out enough that you're not like backlogging each one of your basically batch runs. However, it's the most ideal way to deal with these large document changes. So you might be saying, what if I have small document changes and I need the documents reflected like immediately? So that kind of takes you to our proposed solutions matrix for our incremental solution. So again, small document changes, even in a batch or incremental delivery, it does warrant an incremental and real-time solution, right? So, you can process the small number of documents in a streaming fashion and kind of share that with the same quota, so your chatbot doesn't basically grind to a halt. I would add that you'd probably have to rate limit the documents being added to your knowledge base to basically ensure your online quota integrity. We can kind of talk about that later. In the worst case scenario that you can possibly have is if you have large change of your documents in an incremental or intermittent solution. That's tough because you can't do a batch job because it takes too much time. And if you have a large change in documents, you will consume your quota extremely quickly. So this is kind of a unicorn case. And I don't think a lot of people see this because knowledge bases don't really change at like high velocity. However, if you ever did have a use case, then I would probably urge people to use a self-hosted LLM model and replace your quota with QPS. And your QPS would be dictated, or your queries per second would be dictated by the serving resources you provision to your LLM. So with all this being said, I would like to show you these solutions to see what they look like on paper. So our batch architecture, essentially, as I mentioned, it's an ideal candidate for initial vector database and knowledge build. Anytime a change to the pipeline configuration is made, or there's a large change in documents which need to be processed. At the topmost level, we have our orchestration project, and the goal of the orchestration project is, to orchestrate the pipeline. It contains the orchestrator and common pipeline resources, which are shared between other pipelines. We have our project, which we actually execute the job in, which consists of a pre-processing job. This is the component which houses all their lang chain, our basically document loading and processing for the knowledge base. An embedding job, a post-processing job, so formatting those embeddings for your correct vector database or your sync. our knowledge base, and our vector database. So our knowledge base is basically the source of the raw documents, the sink of every intermediate pre-processing step. So the raw chunks, pre-processed and post-processed embeddings, it houses all of that. And again, we're going to cover how the knowledge base is configured and structured in a bit, but you can see it, it's right there. It should be kind of the start of everything. A brief description of the tools that we used. Orchestration, we use the GCP managed service Cloud Composer, which is basically Apache Airflow under the hood. Extremely popular orchestrator and workflow management platform. For all processing steps, so pre-processing, post-processing, we use Apache Beam. You know, it's an open source unified programming module to define and execute data processing pipelines in basically an ETL batch and streaming fashion. It's particularly useful for parallel data processing tasks. So in the case of our pre-processing stage, you know, our small bundles of data represent our individual documents to be processed, and in our post-processing stage, the small bundles of data represent the individual chunk embeddings. Now, the vector database we have listed here is GCP's vector search. However, I want to stress that you could replace this vector database with your choice, just as long as your post-processing component is extended to properly format the embeddings. So that's our batch solution in a nutshell. So if we look at our incremental solution, you can see that we've already established that batch is ideal for rebuilding the index and large document changes. However, it's far from an ideal solution. We have high velocity documents. So again, stated, when we have small batches of documents being refreshed periodically or intermittently, and the changes need to be reflected as soon as possible, you kind of lean towards this solution. You should note that we have many common components and elements as the batch pipeline, right? So you have the knowledge-based bucket, which does not change. We echo the same sentiment for the vector DB. The largest addition to this architecture is the pub subtopic, which listens to all the changes which occur in our knowledge-based bucket. So when a document's added, updated, and deleted, that message is published to that topic. In this pipeline, we have one data flow job, which encompasses the pre-processing, embedding, and post-processing. And basically, we listen to that topic, we bring it, we can say, oh, this file has changed. We can point directly to that file and load that file atomically. Some of you might be asking, why PubSub? Why not a cloud function? Or if you're on AWS, a Lambda function, or Azure, I forget what it is on Azure. The answer to that's race conditions. So let's say you're a librarian and you upload a bad document and you realize it instantly, you're going to try and delete it right away. We've all done it, a misclick, a whoopsie, or whatever. Cloud functions are isolated atomic events. There's no coordination between them. So the first action of upload will cause the bad document to start being processed. The second action of delete will remove all existing documents in parallel. Will exist all old documents in parallel. Now, since the deletion process is a fast operation, it will finish before the bad document is finished processing. When the bad document's finished processing, it will upload and sync those bad chunks to your vector database and knowledge base. And now your library is out of sync. So with PubSub plus Apache Beam, you can window and group events. If we define a sliding window of 60 seconds or X amount of seconds, our job will only take the most recent action within that window, and therefore we can only focus on the most relevant action. So seeing kind of both the batch and incremental solution, you might be saying, okay, well, which one do I pick then? And the answer is both. Like what we have done at Bell is we've created a hybrid solution. We can stick them together and they kind of account for each other's shortfalls. Yes, there's a little more, I would say, orchestration and involved, but you really get the best of both worlds. So the batch pipeline is the primary pipeline. Every use case requires one. It's used for initialization. It can be scheduled to run on periodically or triggered event. And it is key for creating and refreshing your knowledge base from a large document change or configuration change point of view. The incremental pipeline is completely optional and supplementary, but if you have high data velocity situations, you can include it. So the workflow would be the data pipeline's triggered, the orchestration will drain your incremental pipeline, stop acknowledging and accepting messages from your pub subtopic, stop the incremental data flow job, launch the batch pipeline, which will process the entire knowledge base, complete the vector DB and knowledge base sync, restart the incremental pipeline. Any changes which have made be during to the batch pipeline to the knowledge base will leave unacknowledged messages in the pub subtopic. And when the incremental pipeline restarts, it will consume those messages to reflect the most recent changes. So again, what you're left with is a nice harmonized solution, which kind of gives you the best of both batch and incremental pipelines. I do want to highlight that every component within a yellow and purple box can be treated as an independent configurable service, which are governed by essentially a configuration file or a DevOps process. Now, you might be looking at this and you might be saying, wow, this is a lot of development. It seems pretty heavy to deploy, but in reality, it really isn't. So let's look at the deployment effort required to kind of produce this architecture. So your first step is a YAML file. Each one of our components that we listed on the previous page are totally configurable. So, you know, your pre-processing customization or your pre-processing job, you can specify the loader, the chunk size, the chunk overlap, separators, your region, your product, even the version of the service we're offering, and the URI of the source and sink. Your embedding services, as Lyndon alluded to, if done right, you should be able to interchange the embedding model, the region, the product, if the endpoint, if it's a self-hosted model, all of that should be configurable. And for post-processing, again, you should be able to specify your vector DB sync, the region, the project where it actually lives, and then the URI of the source of your knowledge base and the URI of the sink. So every single one of these services are, you should think back to when we were trying to instill those best practices. It's modular, and you have basically each one of these processes are testable and customizable, right? So, and they're all dictated by one YAML file, right? Which we consider the serving resources. So you're probably saying, all right, I have my YAML file. Well, what now? What about all of those components, right? That we've been talking about. So basically, we treat each individual component as a service. So again, alluding to what Lyndon said about software engineering best practices, it's modular, it has its own specific role and function following separation of concerns. And these components are also built and maintained in a proper DevOps fashion. So there's a variety of one-time resources which are required for the RAG pipeline to run. So that those include your data flow flex templates and containers, the initialization of the knowledge bucket in the target environment, creating the pub sub and bucket notifications, and then initializing the index with specified parameters. So through the magic of, you know, infrastructure as code and our DevOps team, who are the real heroes, if you're watching, thank you, we can treat these components as products and offer them to services. So doing that basis allows to create a unified and supported interface between each component, which allows us to use the same containers and code for every single RAG use case, which means you don't have to do any additional coding to launch a use case. It should be baked into the product as a service. So you might be saying, all right, I have my YAML file. You've already pre-built my components. How do I deploy the workflow? You have to talk about DAG generation. So instead of defining a custom pipeline for every use case, we've created a standardized pipeline process that can be applied to every RAG use case. So zooming in on the orchestration aspect of the hybrid solution, we can see we've created a standardized DAG definition. Now we are missing lots of DAG operators in there. This is high level, but use your imagination. So essentially, this is a standardized pipeline based, and we inject our YAML configuration file into these operators. So in our implementation, all you need to do is create a YAML file, configure a CI/CD pipeline to move that YAML file into your Cloud Composer instant, and then once uploaded, a DAG generator automatically creates the associated DAG for your use case with your specified parameters. So really, all components are reusable across pipelines, no additional developments needed, and this allows you to deploy a pipeline within minutes in almost a low code, no code type of fashion. I can't say no code because the YAML file, I guess, is a bit of code. So now that we've standardized and productionized the components, basically the intermediate components between and the interface between these components, we can now talk about how we manage and structure the input of the pipeline, which is our knowledge base, finally. So some of you might know what this picture is, and some of you might be saying, why are we looking at a TensorFlow extended workflow or a screenshot of a TensorFlow extended workflow? For those of you that don't know, TFX is just basically a framework of components that implements an ML pipeline, which is designed for scalable and high performance machine learning tasks. And again, you might be asking, why am I looking at this? And it's because to design our knowledge bucket, our knowledge base, we took heavy inspiration on how TensorFlow extended stores its experiments in its pipeline route. So, oops, sorry. There we go. The pipeline route essentially is defined for a specific use case or pipeline, and each experiment and run for that pipeline creates a subdirectory within that pipeline route. So the run ID is a unique string that's generated for each run and is most likely a combination of runner and date time. So in TFX, you can use the run ID to view logs for a run, download the artifacts from a run, and compare the results of different runs. This is what we tried to emulate. We tried to emulate the same behavior in our knowledge-based management solution. You can see the screenshot over there. The pipeline route is tempfs, temp, and the run ID is TFX interactive with a timestamp on it. And everything associated with that experiment will be in that run ID. So with what we've done with our knowledge base and how we've defined a knowledge base, it's just a bucket. It's a very organized and very structured bucket, like a library. The goal is that every use case has its own root folder in the bucket, or as you want to continue with the library analogy, section of the library, which contains a curated and managed raw document subfolder, curated through a librarian or automated pipeline, a folder which contains processed chunks, and a folder which contains processed embeddings. The goal for every batch pipeline run or any change in the configuration that warrants a batch pipeline run, the pipeline would create and writes to a temporary and intermediate files to timestamped subfolders. That provides the data lineage and provenance for each configuration and each pipeline trigger. So upon each batch pipeline trigger, the most recent timestamp folder will then be synced to the current subfolder, which the chatbot API will be retrieving information from. It's almost like a one common entry point for downstream processes. In an incremental solution, if you choose to use it, the files in the current folder are modified directly, and we don't require a timestamp subfolder because the files are, they're being updated intermittently. There is no concept of a timestamp when you're doing things in real time within a sense. So now we can talk about mechanisms for getting raw documents into that raw documents folder. So we kind of have to talk about lane chain. And if you remember, I was talking about lane chain is specifically in that pre-processing data flow job. So at Bell, we've kind of divided the lane chain loaders into two major categories. You can look at document loaders or source loaders. And what I mean by a document loader is a loader which utilizes a specific URI or link to load a singular document, like atomic document instance. So, PyPDF, unstructured loader, BSHTML, you're reading specific documents. A source loader, on the other hand, attempts to process a variety or like undefined number of documents. For example, a directory loader. You're just going to point at a directory and you're going to load all of the documents that are in that directory loader. We tend to focus on document loaders because source loaders would basically require, it only fits the batch solution, right? It would require you to reprocess the entire knowledge base and vector database. There's no notion of which documents you're updating since you are basically pulling every document within the scope of the source. So in our pre-processing component, we need to know exactly which document has changed and only action and process on that specific document. Hence why we focus on document loaders within our pre-processing component. Now, you're going to say, okay, I need to upload documents into that raw folder so I can use a document loader to essentially read from my knowledge base. How do I do that? There's two methods. There's two methods that we've kind of coined here, Val. And one is the librarian, I can't say coined because we don't own it, but the librarian approach, which having a person or a collection of people explicitly perform operations on singular or defined groups of documents. So it's a person who's sitting, think of your file explorer on your computer or eSpace or Google Docs. You are dragging and dropping specific files or deleting specific files. And those can be reflected in the raw folder of our knowledge base in real time or periodically if you'd like. So that is the simplest solution to essentially say, okay, I know these atomic document changes are happening, and my document loader can look at that and process them. Or a source loader, you cannot do that. So the second method to basically sync, if you don't want to appoint a librarian, you can build an automated pipeline to do this for you. However, it is definitely more involved. So next slide, Lyndon. So the automated pipeline is basically the process of implicitly determining which documents have changed at the source and reflecting only those changes in the knowledge base. So the process would be kind of grab a list of all your documents and content from the source, maintaining an intermediate landing zone between the source and the knowledge base, and then you have to dictate your action. So if a document's missing in the source, which exists in the landing zone, you have to remove it from the landing zone. If the contents of the document source varies from the landing zone, then you have to replace the landing zone document content from the source. Once you've done your comparisons, you've done basically, I know which documents have changed. There's multiple different ways to do this. This is an example. You can use timestamps, for example. If you have a source like Confluence that will tell you which pages were deleted or which pages were updated, you don't have to do this comparison. You can explicitly grab which pages have changed, right? So this is just a very high-level generic kind of workflow. However, it does depend on your source. Once you have your basically your intermediate landing zone is synced with your source, then you perform an rsync to your knowledge base, and you set basically an rsync will only provide, essentially, it will only make changes to the documents which have changed or which have in fact changed. So I'll remove documents that don't exist in the landing zone anymore, and I will update documents which either have changed in size or have a different creation date on it. And then by doing that, now I can point my document loader, which is my pre-processing step, to my raw documents. And I can basically do those atomic updates that I've been trying to stress throughout this entire presentation. So those are the two solutions. We've actually implemented both at Bell. So we have a couple Confluence solutions that are based on the automated pipeline, and we have a couple solutions that are based on the librarian aspect, where people are manually curating your documents. So I hope what you have gotten out of this presentation is a full end-to-end of how we've orchestrated our components to be reusable, and then through rigid structure and defining your knowledge base in a very structured manner, how you can basically abstract away these services into like a YAML file. Define your source, define your pipeline route, define your document type, and you're off to the races. So Lyndon, that's really all for me. Thank you so much for taking time to listen to this presentation. We know we are entering the QAA section, and I think we have about 10 minutes left, if I believe. But yeah, Lyndon, I don't know if you've been reading the QAs. Have you picked any good ones, or?
Yeah, I think we've got a few that we can go over quite easily. But before that, I did want to also just continuing on the point that Adam was making. Like, what is the so what, right? Like, so what? Like we built a RAG pipeline, but essentially, it whether your documents are in a storage bucket, are your documents on any sort of cloud, are they on a different other source, as long as they can be connected to. What are the different types of, does your document need a different type of pre-processing? Do you want to, specify a custom pre-processing, etc.? And then is it an incremental situation? Is it a batch situation? Is it high velocity, low velocity? Right now, what we've built is a solution that can work for all of these situations, and it can work for constantly changing knowledge bases as well. And I know there were some questions on like why are the knowledge bases for some of our use cases so dynamic? Well, some of them they're not. They're really not. Like some of those use cases, like the HR policy one, that's probably not an example of a very dynamic knowledge base, but we have gone through several use cases at Bell where the knowledge bases are expected to change. Some of them are related to some of our automation functionalities, right? So in those kinds of scenarios, the knowledge bases are subject to rapid and dynamic change. And basically, we don't have to go in and build a separate pipeline every single time. We have this system and these components, and like Adam was saying, go change the YAML file. Our deployment is going to be quite straightforward.
Yeah, and the knowledge base, exactly. Like I've tried to convey that the incremental aspect of this, or the real-time aspect of this, it's not necessary, right? Our HR policies are a great example of documents that are updated once a quarter. I schedule a batch pipeline, and I walk away from it, right? But let's say tomorrow we have a over-enthusiastic HR prime who wants to change HR policies every day. It's a flip of a switch. You can accommodate those incremental asks if need be without having to reinvent the wheel. A couple other questions here good questions. Did we come across any challenges or performance issues using LangChain document loaders? The answer to that, it's a loaded answer, but it's no. And the reason why I say no is because the frameworks that we used in our pre-processing, Apache Beam is extremely elastic. It's super scalable. If we are seeing a bottleneck within our pre-processing, you can always increase the number of workers. You can always increase the machine types. Like that's all configurable within that YAML file that I was talking about. So if you are seeing a bottleneck, it's super, super easy to be like, well, we can actually auto scale that component up, which is the great part about being a microservice or treating it as an individual component. Your follow-up question of how do you decide on chunking method and size of each data source of your pipeline? No, we definitely do not use the same method and size for all data sources. We have a wonderful, wonderful team of data scientists who basically sit down, and they, depending on the type of the documents and the content of the documents, they come up with optimal chunking parameters. Outside the scope of what we've shown you, we have a great feedback loop of on the chatbots showing thumbs up, thumbs down, and they're consistently tweaking. That, right? So, chunking size or overlap, or, even if you want to talk about like the actual vector parameters. And again, to make those changes, it's just a quick change to a YAML file and you redeploy and you're off to the races. So I hope I've answered your question there. Another question in terms of, sorry, Lyndon, I'm just rapid firing these if that's okay. Do you have a way to only embed parts of updated document, or do you re-embed the whole document for every update? Yeah, the way we treat documents as like kind of a unit, right? So it's so hard. Okay, so if you've changed, for example, the part of, if you've added 1 or 2 sentences in the middle of a document, there's no real efficient way that we found to preserve the first couple chunks and then only process the next couple chunks. The underlying assumption is if you changed a document, just start from scratch, remove the chunks that basically re-exist, rechunk everything, and upsert everything in the vector database and knowledge base. It just gets a little hairy in terms of trying to do that coordination. I wish I was a better software engineer and I could do that, but for the amount of time it would save just to reprocess a document, I don't think it would warrant it necessarily. Lyndon, would you like to deal with the, you know what? I know there's a question on using self-hosted LLM and Google. I know you've worked really closely with Google, so I'm going to direct that one to you if that's possible.
Yeah, so the LLM here is not self-hosted. It's Gemini is what we're using, and the embedding model, the embedding LLMs are also from Google. Privacy concerns. So at Bell, we've got a large CorpSec and privacy team, and they've made sure to go through MSAs with Google and the LLM services that Google provides to ensure that there's no privacy concerns in here. That being said as well, a lot of the use cases that we have implemented using RAGs are insisted on not sending any sort of PII. So if there's any PII in any of the use cases, that gets either redacted or completely removed before it's going to the LLM. So even in that scenario, there's little to no privacy concerns.
I see another, or sorry, Lyndon, do you have one? Go ahead.
Yeah, there were a couple of questions on the, is there a GitHub repo? So we've not made the source code for this public. So there is no Git repository available. However, if you would like to learn more about the solution and use it for, if you're curious about how can this solution be used in RAG solutions within your corporation or your organization, feel free to reach out to us, and we'd be able to, engage and talk through, how we can support there. And I've also posted both Adam and my emails and LinkedIn's on the chat here. So, in any situation, either for the deck or the presentation slideshow or the, any other further questions on how to use the system that we've built, feel free to reach out to us. Yeah. Or even if you just have random questions on LLMs and MLOps, we'd be happy to talk about it.
Yeah.
Yes, there was a question on I think it was the first question, number of vacation days could be easily answered from the CRM using SQL. There is a large category of queries. Yeah, that's very true. Yes, the HR bot that we showed is meant to also answer questions in not just vacation days, but like specific HR policies that where the database itself is not cannot really be organized in a relational manner, right?
Yeah,
and a lot of it context related. We've got several different teams, just being the large enterprise that we are. There's several different types of teams, each with their own distinct policies, and so the bot there is also able to handle, making sure the right person is redirected to the right type of HR policy. Right? So the number of vacations there was just an example.
Yeah, it's not such a clean cut at vacation at Val. As Lyndon alluded to, like there's a vast variety of teams and roles here. So, we do have union employees in network, for example, and for them to, if they ever make the jump to management, they might have questions like, do I bridge my service? Can I bridge my service? Or like techs, for example, I was a tech, I've moved to a different role. How does that work for vacation? It's not just, like other companies, it's like, oh, I've been here for 7 years. It should be a clean cut answer. Typically, like, it's really not. And there's actually quite a bit of documentation kind of on that subject. So, it's not just defending that example, but yeah, it's definitely a more complex topic than just like a CRM or like SQL, right? There's nuances that, we have pages and pages of HR policies and not enough HR primes. So that's kind of was the reason behind that chatbot.
There's one other interesting question, Adam, if you would want to answer, which is what were the data sources? Was it Google Drive? And for this kind of data that needed such complex data engineering pipelines? And was it real-time uploading as well?
Yeah, absolutely. So I will talk to the Confluence use case, right? So, most use cases, they can be managed with a librarian, right? Like an HR policies is a great example of someone uploading documents. They're slow velocity documents. However, we have a couple Confluence use cases where people are updating Confluences consistently or by almost like daily. So that requires, okay, we don't want to refresh our knowledge base every hour or every 10 minutes. So what we're going to do is we're going to have that pipeline essentially only query and pull in pages which have been changed, right? And then that allows you to basically target those pages and reprocess only those pages. So that's an example of like a high velocity like use case where someone's just like, oh, we use this Confluence, people reference it all like every day. And it's for like a chatbot or something like that. It can be changed. It's fleeting. It can be changed every day. That's a great example of something that needs to be updated next to real time because those policies are changing. So another question, handle data with images and tabular. I don't see why not, right? So I did include in one of those slides there multimodal embeddings. So sky's the limit, right? If you can take it and create an embedding, I don't see why not, right? So I don't think we have any immediate use cases in our future, but I think it is on the roadmap. I think it is on the roadmap. So it'll probably, like all software engineering, it'll become a priority when someone wants it, and then it will catapult to the front. But until that happens, I think it's kind of back burner for now.
Yeah, the good thing though is because the solution is modular.
Yeah, exactly. Well, you're pointing it to a different model or different endpoint, and you're off to the races, right?
Awesome. So I think that covers almost all of it. And I also see a lot of thank you and great presentation kind of comments in the Q&A. So thank you so much for that. We're glad you like the presentation and like the Q&A as well. Like we said, please stay in touch. We've shared our contacts. So, if you need any more information, yeah, and there's one question that just popped up that I'll quickly answer. Can this be consumed by any other team for their kind of data? Yes, it can be. So,
yeah, I will run through this really quickly. The great part of this is that all of these products we've localized into one project. So you can run these pipelines on your, basically, if you have a project with your own data within GCP, you almost treat this as like a pipeline as a service. And you can be like, okay, we will take your documents, we'll ingest them, and your knowledge base can live on your project, your vector database can live on your project. We will basically use what we've built and we will ingest and put it back. We won't even store your documents for you or your information if need be. That's how configurable these components are. So yes, absolutely. Any other teams can definitely use this. So yeah, sorry. Thanks.
The pipeline available is not open source. There was just a question here that is the pipeline open source in the docs? No, they're not. But again, feel free to reach out to us and we can talk through how we can support any systems that you're looking to develop. But awesome, yeah. So that being said, thank you everybody for the for coming to this presentation towards the end of a day. And yeah, hopefully, there's some good information to take out from here. Feel free to reach out to us. Thanks, Adam, for the great presentation as well.
Thank you, Lyndon. Thank you.
And yeah, hopefully Canada can make it to the Copa America finals the next time. But yeah, hopefully you all have a good TMNS, the rest of TMNS as well. So hopefully
Yeah.
everybody enjoys.
Thank you, everybody. Much
Thank
appreciated.
you. Good evening.